क्या कर रहे? क्या कर रहे?
Sir,
Good afternoon. So there are only two participants. What happened?
सर लोगों को इन्फॉर्म करना पड़ रहा तब वो ज्वाइन होते हैं।
ऐसा क्यों? उनको मालूम नहीं क्लास है?
सर पता नहीं क्यों ऐसा क्या है कि वो जब तक बताओ ना तब तक वो ज्वाइन ही नहीं होते हैं।
ओके. So let's begin. Is my screen visible to everyone? Hello?
यस सर।
क्या मेरी स्क्रीन? हाँ, तो बीच में बता दीजिए जब भी स्क्रीन नहीं दिख रही है या मेरी.
स्क्रीन
हाँ, बताइए बताइए.
विजिबल है।
विजिबल है ना? ओके. So what we were doing last time, we were defining something called linearly independent. We define linearly independent set. We define linear span of a set. Then we define basis. And the last thing we proved was this theorem, which says that if we have a vector space and say it has a basis containing n elements, then any linearly independent set of n vectors in V is a basis of V. So in a vector space, if you have any, if you have a basis of that vector space, then any set or a set which is linearly independent and it contains n elements, then it will be a basis of V. So this is what we proved last time. Next thing is, so say if we have two bases of a vector space, then what can you say about the cardinality of these bases? Okay. So you all know basis is a subset of a vector space. So now we take two bases and then we are interested in the cardinality of the basis. Cardinality means number of elements. Okay. So next theorem is that V be a finite dimensional. So why are we taking finite dimensional? Because in case if V is infinite dimensional, then by definition of a finite dimensional vector space, a vector space V is finite dimensional if it consists a basis of say n elements or finite number of elements. Okay, so V is a finite dimensional means its basis contains finite number of elements. Then any two bases of V have same number of elements. So here it is saying same number of elements. It is not saying that they have same elements. Okay, same elements and same number of elements are two things. So how they are different? Suppose A equal to 1, 2, 3 and B equal to A, B, C. Correct? So A and B, they are different, but the number of element is in A and number of element in B is 3. Okay. So here, please see the difference. Okay, let's do this. Proof. So how do you do this? Assume we have two different bases, E1, E2, En, and two different bases means take these, these two sets and assume that these two are bases. So in first set, we have n elements here, we have l elements here, m elements here. Okay. So n and m both are n and m both are positive integer. Okay. So then by trichotomy law, one of them, so three things happen if one sorry equal to m then m or then we are done. If these two happen, then we proceed. Okay, then suppose m is greater than n. Correct? So m is greater than n means this part we have already done. How? See, m is greater than n. This means m is greater than equal to n plus 1. So f1, f2, fm, cardinality of this set is greater than n plus 1. And you know we had proven in a lecture that if we have a finite dimensional set, finite dimensional vector space, and it has a basis with n elements, okay, then any set of vectors in which there are n plus 1 vectors, that set will be linearly dependent. So this set will be linearly dependent. Okay. So this implies, since this has n plus 1 element, f1, f2, n plus 1 is linearly dependent. So what does it mean? So it means there exists, okay, so this is m. There are scalars alpha 1, alpha 2, alpha m such that linear combination 0 and some of these alpha is are non-zero. Correct? Some of alpha i's are non-zero. Okay, but you know that this is a basis, f1, f2, fm is a basis. So you can write 0 f1 plus 0 dot fm equal to 0. So if you observe by the definition of basis, we observe that the 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 linear combination of fi which gives the vector 0, it would be unique. This implies then implies all alpha I will be 0. Okay, because f1, f2, fm is a vector space. This implies right is since F1, F2, Fm is a basis, and by the definition, if the set is a basis, it will span whole of V, whole of vector space, and that linear so this means every element of the vector space can be represented uniquely. So this is very important. So every vector in the vector space can be represented as a linear combination and of this Fi, and this linear combination is unique. From here, therefore, this alpha equal to 0 for all I equal to 1 to m. This is a contradiction. It is a contradiction. Therefore, our assumption is wrong. So this implies m is less than equal to 1. Okay. But similarly, you may argue that now if n equal to m, then there is nothing to prove. If this is, then we are done. If n is greater than m now, so here we took m is greater than n. Now we are taking n is greater than m. Okay. So this means now we will consider this set E1 to En. Here n is greater than m. Sorry, here n is greater than m. And you know F1, F2, Fm is a basis, and n is greater than m, which means n is greater than equal to m plus 1. So any set which contains more than m plus 1 vectors will be linearly dependent. So this implies E1, E2, En is linearly dependent. And the same procedure we will get n is less than equal to m. And in the above, what we get m is less than equal to n. This then implies n equal to. We are done. Okay. So arguing as above. We have any question? Hello? Is it okay? Is it correct?
Yes, sir.
Okay.
Yes, sir.
So this means if you have, so in a vector, so you see in a vector space you may have more than one basis. Okay. And but the thing is, every basis contains the same number of elements, and then there is, so we have seen that basis has some number of elements. So is there any concept in vector space which gives something from this number of elements on a basis? Okay. So why this number is important? What is its significance? The number of elements of a basis. Why is it important? Why are we talking about this? Why are we uh, bother about this number? Why are we bothering about this? So let's see. We are bothering about this number because it gives an important notion that is called dimension of the vector space. Let's define the dimension of a vector space. We say a vector space V is of dimension n if has basis consisting of n elements, and from the above definition, what you would infer then, we say a vector space V is of dimension F if its basis has n element, because so here it has a basis consisting of n elements. In fact, every basis will have then n element. Okay. So let's see some example. Number first, uh, what is the first example that we come across? Uh, so first example that we come across of a vector space is, so what was that example? Can anyone recall? What is the first example and simplest one? So the simplest example was this space. This is called zero space. Okay, zero space over say R, over the field R. What would be its basis? Hello? Hello? Am I audible to everyone?
Yes, sir.
What? So we have this zero space. Okay, zero space is spanned by zero. So what would be its basis? Any guess? Okay, what would be its definition? Any guess? Guess. Its dimension.
Sir, the finite number of element in basis is called dimension.
हाँ, ओके. तो वही मैं पूछ रहा हूँ, बेसिस क्या है? ओके, व्हाट इज बेसिस?
स्पेस की बेसिस 0 ही होगी.
ओके, ठीक है. बेसिस की डेफिनेशन के मुताबिक बेसिस में क्या क्या प्रॉपर्टीज होनी चाहिए? बेसिस स्पैन ऑफ बेसिस
लीनियरली इंडिपेंडेंट वेक्टर्स होने चाहिए और जो कि व्हिच स्पेन्स द वेक्टर स्पेस.
हाँ, लीनियरली इंडिपेंडेंट. ठीक है. तो ये दो चीजें होनी चाहिए जो मैंने अभी अभी लिखी और आपने बताई. ठीक है, ये दो चीजें, स्पैन ऑफ बी इक्वल टू वी एंड लीनियरली इंडिपेंडेंट. Clearly, span of B means here span of 0 is V. Is 0 a linearly independent set? Is this linearly independent? Is it true? हमने क्या बोला था? कोई सेट जिसमें 0 होगा वो कैसे सेट होगा? हेलो, आपको याद है
लीनियरली इंडिपेंडेंट है.
हाँ, लीनियरली
इंडिपेंडेंट
है
और उसके पास ओनली वन एलिमेंट है.
तो जिसके पास ओनली वन एलिमेंट होता है वो लीनियरली डिपेंडेंट हो जाता है क्या?
लीनियरली इंडिपेंडेंट सेट.
So unfortunately, this set is not linearly independent, not linearly independent. So this is very unfortunate.
Sir, why it is not linearly independent?
Huh. So give me a reason. So we have discussed this. Can you remember? Can you recall it?
डायमेंशन 0 है.
ओके अभी देखते हैं. डायमेंशन 0 है, ठीक है.
सर पूछ रही हूँ, मतलब ये मेरा क्वेश्चन की डायमेंशन इसका 0 से ही मैं बता रही हूँ.
हाँ आपका गैस करेक्ट है, डायमेंशन 0 है. आपने जो गैस किया वो ठीक है. अगर डायमेंशन 0 है तो क्या होना चाहिए? तो इसका बेसिस में कितने एलिमेंट होने चाहिए?
0 सर.
0 होना चाहिए. अगर किसी ने बोला कि 0 इसका बेसिस है, इसमें तो एक एलिमेंट है 0, तो आपकी वो जो बात थी वो डायमेंशन 0 होगा, वो तो ट्रू नहीं होगा ना. इसका फिर डायमेंशन 1 हो जाएगा, क्योंकि यहाँ पर एक एलिमेंट है.
जी सर.
और ये एलिमेंट लीनियरली इंडिपेंडेंट कि आप कोई भी जीरो वेक्टर लें और लीनियर कॉम्बिनेशन ये रखें तो आपको हमेशा 0 मिलता है. That's why 0 is not linearly independent. A set which contains 0 is always linearly dependent. ये हमने देखा था. A set contains 0 is always linearly dependent. This is we have discussed. So this means from this discussion what we inferred that 0 is not a basis of V equal to 0. But what you know is basis is a subset of V. Is it correct? Basis is a subset of V. Then what are all subsets of this set? Are all subsets of V? Can you tell me?
नॉन-एम्प्टी सेट फाई.
अच्छा उसको एम्प्टी सेट कहते हैं, नॉन एम्प्टी नहीं, एम्प्टी सेट.
सॉरी सर, बाय मिस्टेक हुआ.
हाँ तो एक सेट, ये जो सेट है इसके पास कौन कौन से सबसेट होंगे? एक एम्प्टी सेट, देन वन मोर इज देयर,
The set is itself.
okay. So if you remember, you know the cardinality of power set with n element क्या होता है? 2 to the power n. याद है? एक सेट जिसमें n एलिमेंट हैं उसके कितने सबसेट होते हैं? 2 to the power n. So here n equal to 1, total subsets are 2. One is empty set, second is itself. Okay. So but what we infer from this, so we have already seen this is not a basis. Then the second candidate for basis would be empty set. There is only one choice for basis. So this means the empty set be the basis of 0, the vector space 0. And since empty set does not contain any element, its cardinality is 0. Therefore, dimension of this set is this vector space is 0. Okay, then next question. Say R2 over R is a vector space. What is its dimension? Do we know any basis of R2?
2 dimension. 2
dimension.
Dimension is 2. Okay, give me a basis.
Sir 0, 0.
0, 0. and
1,15.
1,1. Okay, let's see whether this is basis or not.
Sir,
So
1 comma 0 0 comma 1.
okay, so this is B1, this is B2, 1 0 0 1.
1,
Any
0.
other?
Yes.
Any other candidate for basis? So say, let's see what happens when we take
1 comma
B1.
0 and 0 comma 1.
Okay, so this is B2 I have written. So let's see for B1 whether this is basis or not. Okay. So what is a basis? Basis is uh, a subset of V, non-empty subset, which spans it would span R2 and it is linearly independent. So is B1 linearly independent? First question. Second question, whether span of B1 is R2. Second question. So if we answer first one, so we have this statement here. See this statement. What does it
The
say?
set which
It
contains
says
0 is always linearly dependent.
so a set which contains 0 is always linearly dependent. So B1 is containing 0, the vector 0. So this is linearly dependent. So first one is not correct. Next, whether it spans B1, whether it spans R2. So let's take 1 comma 2. Whether we can write this as a linear combination of these two, means whether there exists alpha and beta in real numbers such that 1 comma 2 is alpha 0 plus beta 1 1. Whether is it true? So this means 1 comma 2 equal to beta plus beta comma beta. Beta comma beta. This means beta equal 1 equal to beta 2. So this gives 1 equal to 2, which is absurd,
Not equal.
not true. Okay. So this means this does not span R2. So this candidate is not a good choice for basis. So B1 is
Sir,
not a
एक चीज
basis.
पूछनी-
हाँ,
सर जैसे आपने यहाँ पे 1,2 लिया, अगर मतलब एज एग्जाम्पल 1,2 लिया, या तो R2 के बेसिस में हमेशा 1,2 ही ले सकते हैं
नहीं
Span
मैंने
करेंगे एज
आप
एग्जाम्पल।
कुछ भी ले सकते हैं, आप कुछ भी ले सकते हैं, आप 3.5 कॉमा 100 ले सकते हैं। मैंने ऐसे वो इजी अपना काम इजी करने के लिए लिया। मुझे ये मालूम था कि 1,2 का लीनियर कॉम्बिनेशन ये नहीं होगा।
ओके सर।
ठीक है।
यस सर।
और जब आप ऐसे बहुत सारे क्वेश्चन देख लेंगे, प्रॉब्लम सॉल्व करेंगे, तो आपको खुद ये इंट्यूटिव फीलिंग आ जाएगी कि कौन सा एलिमेंट नहीं होगा। मैंने ये इसलिए लिखा, इसका कारण क्या है, क्योंकि मैं जानता हूं कि जो सेट B1 दिया है, और ये आप भी जानते हैं, थोड़ा सोचेंगे तो आप भी जानते हैं, जो सेट B1 दिया है उसका जो ये पॉइंट 1,1 है। ठीक है। जो सेट B1 दिया है 1,1 थोड़ा सा इधर होना चाहिए। वो क्या है? वो एक लाइन है x माइनस वाई इक्वल टू 0। ओके। ये आपका B1 रिप्रेजेंट कर स्पैन ऑफ B1 है। दिस इज स्पैन ऑफ B1। इसमें वो सारे वेक्टर हैं जो इस फॉर्म के हैं, अल्फा कॉमा अल्फा फॉर्म के, अल्फा इन आर। अगर आप इसको देखेंगे, इसको आप लिख सकते हैं अल्फा 1 कॉमा 1। करेक्ट लिख रहे हैं ना? अब मैंने क्या लिया 1,2, मुझे मालूम है 1,2 इसके बाहर है, यहाँ पर कहीं पर है 1,2। तो वो उसके लीनियर कॉम्बिनेशन के फॉर्म में मैं नहीं लिख सकता। तो इस लाइन के बाहर कोई भी एलिमेंट को आप नहीं लिख पाएंगे। ठीक है,
ठीक है।
आई बात समझ? तो वो एक एग्जाम्पल था, हमेशा ऐसा नहीं लेंगे। ओके, so this is one example. Now a third example, let's see about the complex number c. So you can take c as a R vector space number. So take c set of complex number. There we have two fields there, so we will discuss two cases. Number one, as a R vector space. Number two, considering c as a C vector space, means the underlying field is complex number. Okay, so please tell me, answer B, what would be its dimension of C as a R vector space, and dimension of C as a C vector space. Any guess? So first part, if you have any field,
सर सी वेक्टर स्पेस मतलब कॉम्प्लेक्स फील्ड में?
हाँ कॉम्प्लेक्स फील्ड
कॉम्प्लेक्स
में, हाँ तो इसका बेसिस क्या होगा
आई थिंक
कॉम्प्लेक्स में?
फर्स्ट वाला होगा सर।
फर्स्ट वाला ट्रू क्यों होगा? आपने कहा ट्रू
कोई भी
होगा
कॉम्प्लेक्स,
क्योंकि
ये
हाँ
सर कोई भी कॉम्प्लेक्स नंबर,
कॉम्प्लेक्स
कोई भी कॉम्प्लेक्स नंबर जो होता है सर वो कॉम्प्लेक्स प्लेन में एक पॉइंट को रिप्रेजेंट करता है जो
हाँ
कार्टेशियन फॉर्म में होते हैं सर। तो
हाँ,
वहाँ पे
तो
दो
वो कैसे लिखते हो?
उनके उस कोऑर्डिनेट में। जी सर,
उसको कैसे लिखते हैं? ए प्लस आई बी के फॉर्म में लिखते हैं ना, ए प्लस बी आई, इस फॉर्म में लिखते हो कोई भी कॉम्प्लेक्स नंबर को। हाँ तो एक्स और वाई को मैंने ए और बी लिख दिया। ठीक है, इज दिस ए कॉम्प्लेक्स नंबर?
यस सर।
हाँ, okay, so let's see, this complex number can be written in this form: a dot 1 plus b dot I, where a and b both are, these are
रियल नंबर।
real numbers,
हाँ,
and this one is a complex number, it can be written as a complex number. So this is a subset of C, a 1, and this I is also subset of C. And you see here, any complex number can be represented as a unique linear combination of 1 and I. So someone said x plus iy is a complex number. You can write this x plus iy as a linear combination of these two, 1 comma I, x dot 1 plus y dot I. Okay, in this way 1 comma I is a basis of C over R, okay, of this vector space. Correct? Okay, let's. So this means dimension of complex number, vector space of complex number over R is 2. And what is dimension of the vector space of complex number over C? And
सर
in
टू होगा।
general, okay, okay, ये 2 होगा या क्या होगा देखते हैं। अभी आपने 2 कहा, कोई और कुछ बोल रहा है इसमें? 2 नहीं होगा, 2 गलत है। It is not 2, it is 1.
1 और आई दो एलिमेंट है वो जो बेसिस में सी में जो आपने दिखाया है, तो उसके अकॉर्डिंग 2 ही होना चाहिए।
हाँ तो वो कब था, ये कब था? ये पहला वाला केस डिस्कस करा था हमने, तब था। आपने सुना नहीं क्या?
सर आवाज थोड़ी सी
मैं
कट कट के आ रही थी बीच में। अभी।
मैंने बोला जब हम कॉम्प्लेक्स वेक्टर स्पेस ऑफ कॉम्प्लेक्स नंबर ओवर फील्ड ऑफ रियल नंबर, इसका डायमेंशन 2 है, C ओवर R इज 2, डायमेंशन ऑफ C ओवर R इज 2, वो उसके लिए बेसिस हमने बता दी थी, ये थी 1, ठीक है।
जी सर।
अभी दूसरा केस है, दूसरा केस क्या है, वी आर कंसिडरिंग द वेक्टर स्पेस ओवर C, ठीक है। So you know in C there is a identity element 1 belong to C. Now for any complex number Z in C, it can be represented uniquely as a linear combination of 1. Z can be written as Z dot 1. This means 1 is a basis. In fact, any non-zero complex number would be a basis, would span C. Okay, this, हाँ बोलिए, हेलो, एनी प्रॉब्लम? मेरी आवाज आ रही है आप लोगों को?
Yes, sir.
Okay, so do you see why 1 is a basis? Say yes or no, बताओ कि ये यहाँ पर ठीक है या नहीं है?
Yes, sir.
Okay, so if 1, so this means 1 is a basis, implies dimension of C over C is 1. Similarly, dimension of R over R is 1, because 1 is a basis of R. And if F is a field, and F over F, okay, then the vector space F over F has dimension 1. Okay, this is true for each vector space F over the field F. Okay, you know every field is a vector space over itself, correct? As R is a vector space, R is a vector space over R, C is a vector space over C. Similarly, any field is a vector space over itself, and its dimension is 1. So here is my, okay, so here I ask one question and we will answer it later, okay? We will answer it later. So you all know R a vector space over Q, where this Q is the field of rational numbers, correct? Are you agree with me? Do you all agree with me that R is a vector space over Q? आप लोग सहमत हैं या नहीं?
Because Q is a subfield
हाँ,
of R.
क्या बोले?
Q is a subfield of R.
हाँ, तो Q is a field itself. Q
अच्छा,
खुद
ये
में
तो-
एक फील्ड है, ठीक
Yes,
है?
sir.
ओके, Q खुद एक फील्ड है और R एक वेक्टर स्पेस होता है Q में. R is a vector space over Q. Okay, इसको अगर आपको नहीं अभी दिखाई दे रहा है तो ये चीज इंट्यूटिवली नहीं फील कर पा रहे हैं तो इसको कैलकुलेट आप वेरीफाई कर सकते हैं, एक्सजीएम सेटिस्फाई करवा के। ओके, देन माय क्वेश्चन इज व्हाट इज dimension of R over Q? Okay, so think about it, we will come to it later. Okay, now next example is take n cross n matrices over R. So this is space of n cross n matrices over R. Over R means the entries of matrices are real numbers. Then what would be its dimension? What is its dimension? Dimension of M N R. Any guess? Hello? ओके, सो थोड़ी देर के लिए हम ये थोड़ा बड़ा हो गया तो हम एक काम करते हैं M2R ले लेते हैं, ठीक है। M2R में क्या है? M2R is A, B, C, D. A, B, C, D, these are real numbers. Then find dimension of M2R. So for this, first we find a basis of M2R. Okay, so I'll give you a basis first. So 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So clearly this is a subset of M2R. Span, say this is set S, okay. So span of S is M2R. Any element of M2R can be represented in this form. Can be represented as a linear combination of the elements of S. And second thing is S is linearly independent. Okay, so verify these two. This is an exercise for you all. Verify it. Now tell me what would be the dimension of M2R? Hello?
फोर
हाँ,
फोर
टू बोला आपने?
फोर
क्या बोला? टू बोला कि फोर बोला? हेलो?
Sir, 4. Sir, 4.
Four, because this set S is a basis and it has 4 elements. Okay, so dimension is 4. Now you see there is a relation between 4 and 2. It can be represented as 2 square. Okay, if you take now M and R and take this set S like this, so call, okay, so first we go above and call this first element as E11, second element is E12, this third is E21, fourth is E22. Similarly, we define EIJ, where EIJ is the matrix Xij, where Xij is 0 when I not equal to j and 1 when I equal to j. Okay, so this means E11 is the matrix, first element is 1, then all other are 0, all other are 0. This is E11. What is E1? Say E1n, it would be the entry at first row, nth column, that is this part is 1, all other are 0. This is 0, here all are 0, and all here are 0. Okay, so Eij means the ijth entry is 1, all other are 0. Okay, so how many entries are in a matrix of n cross of order n cross n? So there are total how many numbers or how many entries in a matrix? एक मैट्रिक्स है हाँ n square n square हाँ. So this means the number of elements in S is n square. So cardinality of S, or in other words the number of elements in S is n square. So therefore dimension of M and R is
n square.
n square. Okay. Okay. In last lectures, you told me that the space of symmetric matrices. Okay. Symmetric matrices. The space of symmetric matrices is a vector, is a subspace. Is a subspace of M and R. So then we may ask about its dimension. So what would be its dimension? Space of symmetric matrices. What would be its dimension?
into n minus 1 upon
हाँ बताओ.
n into n minus 1 upon
कैसे कैसे करेंगे? Let's see it. So if you have a symmetric matrix, say for a symmetric matrix A11, this is first entry. If you know A12, you know A21 as these two are same. A12 equal to A21. Okay. You know this entry. If you know this entry, you will know this entry. You would know this entry. Similarly, for A13, if you know A13, you know A31, and so on. If you know A1n, you will know AN1. So then A22. So in first place, you need n vector, n entries, total n entries. In second, so if you know A23, you know A32. Similarly for A2n, if you know A2n, you know AN2. Then you would know A33. So here you have n minus 1 entries. So here you have freedom for n entries. In this part, you have freedom for n minus 1 entries. Then you have freedom for n minus 2 entries, and so on. At the end, you would left with only one element, one entry, that is a and n. Then you would have freedom for only one entry. So total how many entries? N plus n minus 1 plus n minus 2 1. Do you know what is the sum? Hello?
Yes, sir.
What is the sum? Sum of first n
n
natural
into
number
n
is
plus 1 by 2.
n into n plus 1 by 2. Correct. Okay. So, okay, this was intuitive idea. How did you get this? But if you are asked for a proof, then you will give a basis of this space of symmetric matrices. What would be the basis? So the basis will contain, surely it will contain E11, it will contain E12, it will contain E1n, then it will contain E22, E21, sorry, E21 is there already because E2 is there, E23, E2n, then E33, E34, 3n, and similarly at the end En. This would be basis. So first n, then n minus 1, then n minus 2, at the end 1. So total number of element in this basis are n into n plus 1 by 2. Okay, so this is an idea. Please write a complete proof of this. So therefore, dimension of space of symmetric matrices. Matrices is n into n plus 1 by 2. Okay, so space of n cross n symmetric matrices. So similarly, you may ask about the dimension of n cross n skew symmetric matrices. Okay. So what it would be? Any guess?
Yes, sir.
So हाँ बताइए तो क्या क्या होगा?
n square minus n upon 2.
n
n square minus n upon 2.
हाँ ये कैसे आया? किस तरह से आया बताइए? ओके, यही सेम ट्रिक हमने जो ऊपर यूज करी थी वो थी. So if you remember or if you observe clearly, minutely, so what you get? So what are the what is the diagonal of a skew symmetric matrix? What is the diagonal? Diagonal entries क्या होती है skew symmetric matrix की?
E11, E22, E33.
नहीं मैं कह रहा हूँ diagonal entries क्या होती हैं? एक स्क्यू सिमेट्रिक मैट्रिक्स है, उसके डायगोनल में कौन से एलिमेंट होते हैं? क्या आप मुझे कोई एक स्क्यू सिमेट्रिक मैट्रिक्स बताएंगे? 2 क्रॉस 2 स्क्यू सिमेट्रिक मैट्रिक्स. ओके, व्हाट इज द डेफिनेशन ऑफ स्क्यू सिमेट्रिक मैट्रिक्स? आपने मुझे आंसर सही दिया, लेकिन वो क्या आपने कहीं से देख के दिया या आपको पता था? आपने कुछ ऑब्जर्वेशन के बाद मालूम किया?
Any square matrix is said to be the skew symmetric matrix if its transpose is equal to minus of that matrix.
Okay, minus of that matrix. Okay, from here, what can you say about its diagonal?
So I think every diagonal element should be 0.
You think, or is it 0?
I have a little confusion, sir.
So from your definition, Aij equal to minus of Aij, and this is true for all I and j, correct? So for diagonal entries, Aii, diagonal entries are Aii
Yes, sir. 0
equal
only,
to
sir. 0 only.
minus Aii. It means 2aii equal to 0, but 2 is not 0. This implies aii is 0.
is equal to 0. Yes.
So these entries are 0. So you have no choice for this. Okay? You don't have any choice. It's 0. But then if you know a12, you know a21 minus of that. Similarly, if you know a1n, you know an1. So here you have how many choices? N minus 1. Next, you have n minus 2 choices. At the end, you have here one choice. So total number of choices are n minus 1 plus n minus 2 on 1. So what is the sum? Sum of n minus 1
n minus 1 into n by 2.
n minus 1 into n by 2. Correct. So this is what that girl told me. She told me it is n square minus n by 2. If you multiply it, you will get this. Okay. So this is how we find dimension of a matrix. Okay, let's see one more thing, one last thing I'll tell you. Two things. First one is, let's say we take a subspace of M and R, W, all those matrices in M and R, all those square matrices, such that, okay, take this X, such that trace of X equal to 0. So do you know what is trace of a matrix? Hello?
Yes, sir. So sum of the diagonal elements.
Okay, बहुत बढ़िया. Sum if X is given by Xij, then trace of X is X11, X22, and Xnn. So this is sum over Xii runs from 1 to n. So this is called trace. Okay. So what is the dimension of this subspace W? What would be the dimension of W?
n.
Think about it. ये इतना इजी नहीं है, मीन्स इतना छोटा डायमेंशन नहीं है. Okay, before going to so before answering this, let's see another exercise. Say this. So take we are in Rn, v equal to Rn. So you all know dimension of Rn is? What is dimension of Rn?
N.
N. Yeah. Okay, take W equal to this subspace x1, x2, xn such that x1 equal to xn. What is its dimension? So if you see, this W is given by a solution set of a linear equation. Okay, a single linear homogeneous equation. So this x1 equal to xn, so this x1 equal to xn can be represented as a homogeneous linear equation. X1 minus 0 x2 0 xn minus 1 plus minus 1 into xn equal to 0. So this is a homogeneous equation which is same as x1 equal to xn, and W is the space of solution space of this homogeneous linear equation. Okay.
Dimension W equals sir.
Dimension W equal to what is the dimension?
Number independent variable minus number constant.
Number of independent variable minus
Number of constant.
number of constant कितने हैं?
1.
कैसे? आपका आंसर ठीक है n-1 होगा, लेकिन मुझे ये समझ में नहीं आया कैसे.
सर यहाँ पे इक्वेशन 1 दी गई है.
हाँ, यहाँ पर एक होमोजेनियस लीनियर इक्वेशन दी गई है. नंबर ऑफ कांस्टेंट आपने बोला, उस कांस्टेंट का मीनिंग मैं नहीं समझा.
इसके लिए
हाँ, हेलो,
इसको एक्सप्लेन नहीं.
आपकी आवाज क्लियर नहीं आ रही है. अगर आपको कुछ समय पहले किसी ने ये क्वेश्चन पूछा था और मैंने उनको इसका आंसर दिया था कि solution space of a homogeneous linear equation is a hyperplane, and hyperplanes are n-1, so n-1 dimensional subspace. If we are in Rn, so hyperplanes are maximal subspaces, maximal proper subspaces. So this means the dimension is n-1. Your answer is correct, but what is the reason behind this? Let's see a reason behind this. Now, here we are given x1 equal to xn. So for a basis, if we know x1, then surely we know xn. Correct? If we know x1, then we know x1. If we know x1, then we know xn. All other elements, there we have a choice. For all other elements, we have choices. Say for second, we have this, and last one is 0, 0, 1, 0. This is a set consisting of n-1 elements. This S and this S spans W, and it consists of n elements, n-1 element, and clearly this is linearly independent. So S spans W, S is linearly independent, therefore it is a basis, and hence dimension of W is n-1. Okay, let's generalize this. And then we will talk about this part, trace of matrix. Okay, let's generalize this. If here we have only one equation, okay, suppose we have R equations, and suppose we have a system of R equations, system of R equations in n variable, and R is strictly less than n. Okay, R is strictly less than n. One more thing, homogeneous. These are homogeneous equations. Okay, and call the solution set is S. S is the solution space. S is solution space of the system of R homogeneous equations in n variable, and R is r is say less than equal to n, r is less than equal to n, then dimension of this space will be n minus r. Okay, so please this is exercise, please think about it. You do not get any idea, if you don't get anything, then we discuss. I think you will, so if you think about it, surely you will get an idea. Okay, so in above example, this r was 1 and dimension of s was n minus 1. Okay, so one more thing, one last thing for this exercise where we consider trace of a matrix. So if you see M and R, you know its dimension is n square. You all said that dimension of M and R is n square. Okay, am I audible?
हमारी टेस्ट क्लास स्टार्ट हो गई है.
Okay, ये लास्ट है, इसको मैं खत्म कर रहा हूँ. Okay, so you may okay I'll stop here. We will meet next time and then we will discuss it. Any problem? No doubt? If there is no doubt, then drop your attendance.